Kronos. Hi, my name is Kenny. I'll be talking about community outreach. Here are 5 different things we used throughout this process. First thing we did is we in a booth presented our previous year's robot and ice cream social. Then we went ahead and presented it to a 7th grade rookie team. Then we went ahead and presented it to an FLL team at the FLL tournament. Once after that, we went ahead and presented it to a Girl Scout troop at their all-girls competition. Then my teammate Riley Cook went ahead and presented and mentored a rookie team named the Factory Falcons. Now, Riley Cook will go ahead and present.
My name is Riley Cook, and I'm going to be going over overall design and analysis. So last year we found out the PO analysis is very useful. It uses negatives and positives to find the best design for your robot and what to score. So first things first, we put our scoring in, like all the different ways we could score into the PO analysis, and found out that we really wanted to use big balls, because big balls stack well, and the small balls have to use more of them to stack. So then we also want to score on the big goals because then you got more points. And finally we want to move all the goals around but without knocking over because you would lose a whole lot of points. So then we came up with designs for each of them and then made them into different robots of brainstorm and then put that into a PO analysis. But sadly at the end we were very divided. We didn't know if we wanted to use a shooter or a scissor lift. But finally, after we broke into 2 groups of prototyping, we finally came up with what is our robot now. And that was scissor lift with that.
Hi, my name is Alexander McClellan.
And I'm Nikhil Chopra.
And we're going to be talking to you about the belt lift on the front of our robot. This year, we created a belt lift to pick the balls off the ground into the bucket on top as efficiently as possible.
And we ran into many obstacles during the design and build process and took many meetings to get right. But we came up with our final solution and yeah.
To create the belt, we had to look at a lot of different designs. We looked at real-world things. So we kind of sifted through all the brainstorms, and we thought of a golf cart range collector. Nikhil and I both play golf, so we thought of that. Then it turned into one of our flagship brainstorming ideas, and it became one of the lift ideas.
We also had to rotate our lift 90 degrees so it would fit in front because we ran out of space. And we found that observing the way that other robots worked and their mechanisms worked really well because we were able to pick out functions that other robots had and incorporate them to our own. And then we used scoops to pick up our final idea was a belt lift that had scoops to pick up only the big balls because they score more and they were not geared towards picking up small balls.
Thank you. I'm going to introduce Chris and Carlo.
Hi, my name is Chris Mulville and I'm going to be talking about our scissor lift. So we decided to use a scissor lift to lift the balls and score them into the goals because we thought it was the most efficient option regarding space and technology. But while we were building our scissor, we ran into a few different obstacles. One of them being as the motor moved along the track, the gear was binding because there wasn't enough power to lift the scissor. Also, the scissor was too heavy and there's too much stress on the motor to lift it. So we decided to add rubber bands and bungee cords to reduce the stress. And these bungee cords and rubber bands lifted the scissor a little bit before we even activated the motors so that it wasn't as hard to move the scissor just a little bit.
My name is Carla Barstow. I'll be talking about our goal ledge. So one of our most important functions is actually getting the goals and being able to move them into the point loop. So at first, me and Nikhil prototyped a design that used screws to kind of just lift it up, but unfortunately that ended up not working. So we ended up going with a plexiglass design that would just latch onto the goal and pull it behind it. So we could angle it just right, we also put 2 pieces of plastic so we could just run into the goal and it would automatically angle right. Now on the Luca with the chassis.
Hi, my name is Luca Tucci-Barabi, and I'm going to be talking about our chassis and top bucket. So first of all, we decided to use the same drivetrain as last year because it was efficient and we tested it a lot last year. So there's 1 motor in the middle of the robot on each side and 2 smaller motors 2 smaller gears in between the wheels and the motor. We then also decided to add some simple support brackets to support our scissor lift so it wouldn't sway as much and make it a lot sturdier. We definitely wanted to keep our electronic components low as possible so we could keep the center of gravity low so it wouldn't tip over while we were driving around either. We then made the bucket like a funnel so only 1 ball would come out at a time and it would also hold at least 5 balls. We made the bucket out of clear plexiglass so we could see how many balls would be in it at a time and see if there's any potential jams. We made the servo door so balls wouldn't fall out while we're moving the scissor lift up and down, and we created that design so it would help funnel the balls out and so they wouldn't stray to the side or go forward too far. We created some simple shields and bumpers to protect us against other robots and field elements. So now here's Spencer and Ramy talking about programming.
I'm Ramy Benson. I'll be talking about our teleop programming.
Hi, my name is Vincent Romacco.
Once all of our teams decide what motors and controls we're going to use, we start on teleop program. For driver 1, they use tank mode to control both the motors with both the joysticks. They also have the bottom latch so that once they run into it, they can easily know when they're lined up. The second controller has the scissor lifts, 2 motors wired up onto one joystick so that when raising and lowering there would be no error. And they also have the conveyor belt. They also have the top servo to release the balls.
Then for autonomous, first we realized that since it's the same on both sides of the field, we would only need one program for red or blue. Second, we also realized that as the center goal rotated, it had different distances from the parking zone. So, and then third, we use LabVIEW because that's what our high school team uses, and it'll be better for us to be familiar with it when we enter our high school years. Then for our main program, our main autonomous program idea, it will drive down the ramp, it will launch onto a bucket, drop both balls into the bucket, then take the bucket, then take the goal to the parking zone. Then from the parking zone, it will analyze those 3 different distances, and based on how far away it is, it will choose one of the 3 programs and follow that out. Here's Mitchell with the conclusion.
Hi again, I'm going to be talking about some of the major lessons we've learned so far this season. First of all, last year we were a rookie team, so we didn't focus a lot on community outreach because we had so much to do on the robot because we're a rookie team. Now, since we have the advantage of not being a rookie team, we know a lot more about the robot, so we can focus a ton more on community outreach, like Kenny said in the beginning. Also, gracious professionalism is awesome because whenever we need help, other teams are there to help us. And whenever other teams need help, we're always there for them too. And lastly, you always need to check your nuts and bolts and wire connections before every run because if you have a loose bolt before a run, it could destroy your whole match. Thank you for your time. That will conclude our presentation. Does anybody have any questions?
How many sensors do you have on there today?
I think 2. We have the ultrasonic and the infrared.
We only have one, just the ultrasonic. Yeah.
Just the ultrasonic. You're using ultrasonic for your distance sensing then?
Yes.
Okay.
Can you tell me a little bit more about your prototyping and your design process? Using software programs while you were doing that, or how'd that go?
We couldn't really program until we had an actual final design.
Mm.
And then we also broke into 2 teams and we tested them with buckets. And we used cardboard a lot when we prototyping them. And then they also used math to figure out how many brackets you would need to lift it up that high.
We also used Creo, and we spent most of it just trying
We
to design
designed,
scissor.
when we first made our scissor idea, we designed it in Creo.
I noticed some of you are wearing the Turtle Team's bracelets. Could you tell me a little bit about how that happened?
We're really good friends with all the other teams with BH. We try and help each other a lot. Purple Protons, Turbo Turtles, Mechanic Monkeys. We're kind of seen as a group, friends. FLL teams, FRC teams, we're all together, we know each other, and we try and kind of help each other in any way we can. We're not just trying to make ourselves get further, we're wishing great luck so the Turbo Turtles can get to state finals and further, and the Purple Protons can get to state finals and further. We just kind of want everybody to win, not only us.
Yeah, last year they even helped us with our robotic competition. We didn't know what was working. One wire plugged in the wrong slot.
Do you guys have, are you targeting just one height to
It can go any height.
No, it can go to any of the heights.
It can lift all the way to the high goal.
Yeah, the 120 centimeter goal.
And it's at the right height for the logo. We can just pull the logo around it behind us while we pick up balls.
Gotcha. And you're using your ultrasonic sensor today in your testing. How well does it work? Is this deciding based on just that distance with seeing objects that you're using walls to determine how far to go, but what if you see another car in a vehicle?
Well, how it actually works is right when the program starts, it measures the distance And if the distance is less than that distance, it runs that program. If it's higher, it goes to the next one. If it's for the next one, so like 100 centimeters, and then if it's not 100 centimeters or less, it doesn't run that program, and then it goes to the other false where it says if it's 112, if it's less, it'll run the program. If it's not less than 112, it'll run the next program. They're all in one. If it's true, it runs the program. Then in the false box, it has the next set.
I have one more question. Obviously, you guys are really involved in the community. For any or all of you who want to answer, what's your favorite part about all of your community outreach, or what's the best part of it?
Getting to talk about a robot. Anyone else?
Well, I guess spreading awareness for this program. It's a great program for everybody. Even if you don't have a very technical background, you can build one here, which can help you in the future.
It's very fun too.
It's also fun to kind of see the FLL kids. We did a lot of outreach. When we saw them, they kind of, I don't think any of us knew this existed when we were in elementary and lower grades. So it was fun to see their interest in it. It was kind of nice to see that we're making a difference in STEM jobs and things like that for kids.
And then more like the awareness part. Our school does not really advertise it well, so we're kind of helping them so they can get more people to do it.
Yeah, it's great for promoting robotics and science.
I love it when the little 4-year-old comes up to our table and is like, "Oh, what did that do?" It's like, "Oh, it's a robot, just stuff."
What year are you guys in program wise?
Eighth grade. We did it last year.
Kenny's 7th grade.
He's the only 7th grade.
So we have a couple of new members. Ramey's new, Chris is new, and Kenny's new. We've always had one person in a different grade. It's kind of good to see some other kids, but Kenny's really good at what he does. He's really helped the team this year.
So 8th graders, you've been on the team all 3 years?
Yeah.
2 years.
2 years.
Oh, sorry.
Sixth grade.
Yeah.
Sixth grade does that.
And some of us done FLL when we were in elementary school too.
Yeah.
So, yeah.
Thank you.
Thank you guys.
Thanks, guys. Good luck today.
Thank you.
Oh,